And I just thought that was lovely. And I just thought it might be nice to share that one. So this is the best picture of a pigeon at a conference I have ever seen. Let's talk about machines, and let's talk about learning, and let's talk about all the amazing stuff which is happening in the world of technology. And you wake up every morning and you're like, oh, what is this? This wasn't there yesterday. How am I supposed to make sense of all this? Because a couple of weeks ago, I bought one of these. This is it's an Omron smart blood pressure monitor. It's one of those things you put around your arm and you push a button and it tells you how good your blood pressure is doing. And I just sort of, I've hit the age when a gentleman who eats a lot of francesinha should probably start keeping track of these kinds of things. And the first day I got this thing home and I set it up and I put it on and I connected it to the Bluetooth and the Wi-Fi and all the other things. And then I took a reading and I got 5 out of 10. I'm like, that's not very good. And, the blood pressure numbers were maybe a little high. I'm like, yeah, 5 out of 10, that's not a great sign. And so I said, right, let's take it easy today. The next day, I did it first thing in the morning before I'd had any coffee or anything. I got a 6 out of 10. I'm like, all right, a little bit of an improvement. So that day, nice relaxing day, go for a long bike ride and don't get too stressed about anything. Next day, 7 out of 10. Like, hey, this is smashing it. I'm winning. The next day, 8 out of 10. Next day, 9 out of 10. Next day, 10. Look at that. It took me 5 days to get to total health. The day after that, it was 11 out of 10. And that's when I realized that that's just the calendar. It was the 11th of October. My smart blood pressure monitor was not as smart as I was giving it credit for, but it did know what date it was. Now, so one of the things I kind of want to talk about this morning is our expectations about technology and what technology can do. It's astonishing, the stuff which is around us all the time. And so when we encounter something that looks smart, we tend to believe it is smart, even when it turns out it might be kind of dumb. And we have the most astonishing things around us. A couple of weeks ago, my mother was here. She was in the Luangwa Valley, which is in the Zambezi National Park on the border between Zimbabwe and Zambia. This is a place so wild that elephants come up and drink out of the swimming pool while you're trying to swim in it. And I grew up near places like this. When I was a kid, if you wanted to make a long-distance phone call, you had to book your telephone call in advance because there was only one line for the country, and you needed to book a slot on it. A couple of weeks back, Mum is here, literally where this video was taken, and she has enough mobile to do a video call to say happy birthday to my nephew. And I'm like, this is amazing. Like, in the middle of nowhere, you've got enough signal to do that. And I'm sat at my desk, and I'm like, oh yeah, I'm going to have a couple of weeks in Portugal, and I got this machine now that I can go and I can just ask it questions. I'm like, hey, how do buses work in Porto and in Portugal? And I don't need to go and Google and things. It's like summarizes it. It does this, and you go here, and you pay with that, and that's how it all works. And most of this is accurate. I'm like, this is amazing. And then I take a break, and I go for a walk, and I go and I get a cup of coffee from my local coffee place. And they used to do a loyalty card, like a little cardboard thing that every time you get a coffee, you get a stamp, and then when you get 8, you get a free coffee. And they've replaced their loyalty card with an app. And I can't use the app because the people who built the app didn't think that anyone still has a phone this small, so I can't scroll far enough. So a team of front-end and mobile engineers with this amazing 4G cellular data network and touch screens and ARM processors, astonishing technology, have probably spent months of time building something which doesn't work as well as a piece of cardboard. Now, how did we get here? How did we get to a point where you're browsing around the web and there are these, advert-driven websites? And the web is amazing. I think the web is fantastic. And I'm browsing around a couple of weeks ago. I'm in Latvia, which is why the adverts are in Latvian. And I get an advert for Adobe Creative Cloud. I can't give Adobe any more money. I already buy all of their products every month. There is no point them advertising to me. And then I get a pop-up. And the pop-up is like, hey, flights to Portugal. Because somewhere goes, hey, that guy just bought a flight to Portugal. Maybe he's collecting. Maybe he wants another flight to Portugal. How is the internet so clever, and yet it is consistently trying to give me things that don't work, emails that don't say anything, and advertisements for things that I already own? And I think I might know the answer. And I think the answer might kind of cut quite deep to why a lot of us are doing this in the first place. But before we get into that, the important question behind all of this, why does technology matter? Why does any of this matter? Why are we all here to figure out how to build software and use systems and build better networks and work with AI and all these kinds of things? Why does any of this stuff matter in the first place? Well, Douglas Adams, the great British science fiction author, the creator of The Hitchhiker's Guide to the Galaxy, Douglas famously said that the answer to life, the universe, and everything was 42. But Douglas did pretty well. He made quite a lot of money off his books. And you know what he did with all the money that he made from his books? He didn't go around and sit around at home and think about the number 42 and meditate. No. He spent his money on guitars and computers and throwing parties and going on holiday. And by all accounts, he had an absolute blast doing it. He loved doing these kinds of things. And then he went out and he wrote another book. Except he didn't. What he would do is he would sign a contract to write another book, and then he would do just about anything to get out of actually having to write it. He had this famous quote, "I love deadlines. I love the whooshing noise they make as they go by." On more than one occasion, Douglas's publisher would send somebody to pick him up, take him to a hotel, and lock him in the hotel room and force him to write, because they were supposed to be printing a book and he hadn't written it yet. Now, Douglas Adams, he loved being a writer, and he was very proud of the books that he had written, but he hated writing. The mechanical process of actually sitting down and doing the writing, he detested that. And, that, I think, kind of cuts to the heart of what makes any of this stuff matter, because there are two kinds of experiences in the world. There are things that it is nice to do, and there are things that it is nice to have done, but it totally sucked while you were actually doing them. Now, have any of you folks here ever run the marathon? Yeah. Was it fun? Because you look back on that now, right? And you're like, I ran the marathon, yeah, badass. On the day, it's about the 20th kilometer, and you feel you're exhausted. You feel like maybe one of your toenails is actually falling off. That does not, all the people I know who run the marathon, afterwards, they're like, it was amazing. You ask them on the day, they're like, no. It's horrible, absolutely. But then they can look back on it, and they can be like, I did the thing. Now, the day that you ran the marathon, I didn't run the marathon. I sat around at home. I got up late. I drank a cup of coffee. I probably ordered pizza and watched a movie or something. Now, I probably had more fun that day than you did, but I don't remember it. It didn't become part of my identity. I don't look back on it and be like, that was a great day. Look at me. I ate pizza that day. But, I've never run a marathon, but I have done things. I've put shows together. I've done all kinds of things that I can look back on later and be like, actually putting that together was just a lot of hard work, but it was worth it. Absolutely worth it. All of the folks who are going to be up on these stages sharing their wisdom and teaching you things over the next couple of days, if you ask them on Friday evening, hey, how was NDC Porto? They're all going to say, it was amazing, I loved it. If you ask them how they're feeling about it now, they'll be like, no, I hate this. I don't want to do a presentation. I don't want to, I need to update my workshop. Maybe I'll get sick and I won't have to do it. And this is the whole point, I think, is this sort of, this duality between doing the work on the things that are meaningful and being able to go, nah, you know what, not today. I don't want to do that. Having the freedom to do that. And so you're like, I want to run the marathon. And you turn around to your family one day. You're like, you know what, I've decided I'm going to run the marathon. And the family go, well, yeah, that's great, honey. Well done. You can go to work and pay the bills and pay your taxes and buy groceries and make dinner and feed the kids and do the laundry. And when you've done all that, you get out there and you start training for the marathon. We're all rooting for you. And you look at that, you're like, yeah, maybe I'll run the marathon tomorrow. And this is why I think technology matters, is because technology can take all of these, the barriers to being able to get to the meaningful experiences, and it can make those barriers easier. 5,000 years ago, pretty much, I worked out something like 80% of the waking hours on this planet were just getting enough food to not die. You got up, you spent the entire day growing crops or hunting or gathering or foraging, and if you did that every single day that you were alive, you could produce enough food for 1.2 people, which meant that you and 4 of your friends could have enough food to raise a child until the kid was old enough to go out and start foraging for food as well. So we didn't have time to do science fiction and JavaScript and run marathons and invent music. We were busy the whole time. And now we have industrialized agriculture. We have technology. One person with an industrialized agricultural system can produce enough food for about 150 people. which means the rest of them can go out and do other stuff, like marathons and JavaScript and playing guitars and all those kinds of things. 100 years ago, somebody in your house did the laundry, and that took 1 day of their time every single week just to be able to have clean clothes. Today, we're like, yeah, sling it in the dryer, sling it in the washer, and we can go and do something else while that happens. And so this to me is the significance of technology. Now, it would be lovely if we were in the kind of, the Star Trek replicator utopian future where you didn't need to worry about things like food and laundry because you just get up and, replicate yourself a cappuccino and a fresh set of clothes, and then you can get on with going out and running the marathon or sitting on your ass and watching movies all day, whatever it is you want to do. But until we get there, that's why I think technology is significant, is because it takes down some of those barriers to getting to the things that are meaningful. We want to go and spend time with the people that we care about. We want to do the things which are meaningful to us, even if those things are difficult now, because we want to look back on them. We want to be able to travel, to get to the places we want to be and do the things that we want to do. And tech makes all that kind of stuff easier. And you get, the meaningful experiences. You tap the thing on your phone screen, and you get a thing pop up, and it's like, oh, amazing. There's actual food is on the way. The food is being sent to my house. And the first time I ordered takeaway food on an app on my phone, I was like, this is amazing. I don't have to make a telephone call. I can just, it's like a computer game with real pizza in it. This is fantastic. And then the second and third, and after that, it's like, nah, this is just normal now. And so the only time that becomes a remarkable experience now is when something doesn't work. When something goes wrong because your pizza arrives at your door and you're like, I was supposed to get extra pepperoni and I didn't get the pepperoni. What happened? And you remember that because I ordered this. And the reason is that, the reason we remember those, somebody has introduced randomness into what we have tried to persuade ourselves is a completely deterministic, predictable process. This idea of determinism, it's one of the kind of the bedrocks of building a free and fair society is you know what you're going to get, you know how much it's going to cost, and you know that everyone else is going to get the same deal as you. You go into a restaurant, they got a menu, you know what you can order, you know how much you're going to pay for it. If you work a job and you earn a certain amount of money for doing a certain kind of work, you pay a certain amount of tax. Somebody else who does the same job with the same money, they should pay the same tax. Two people who are standing trial because they've been accused of the same crime and the same evidence, they should expect to get the same kind of verdict. Now, out there in the real world, we still have quite a long way to go to get all this stuff figured out. But in the computer, in the world of digital technology, we can normally assume 1 equals 1. Yeah. Always going to be true. 0 equals 0, that one is always going to be true. And some of the most maddeningly memorable episodes in my own career, and I'm sure many of yours, are when the computer doesn't do that. And you ever had a project which has a flaky test, and you just got one test that sometimes fails? And you don't know why. And you say to when you join the team, you're like, hey, what's with this test? They're like, I'll just run it again. And you run it again, and maybe this time it works, or maybe you need to run it 2 or 3 times. But eventually, the test always works. And the only thing, if you don't get what you want, bang, pull the handle, run the test again, ching, 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 there we go. We can go to production now. And then one day, you're like, nah, I'm sick of this. I am going to show the machine who is boss. And so you open it up. And you put diagnostic logging in production, and you get the log files for that. And you write one of those tests that runs the same thing in parallel on 100 threads at the same time, 200 threads, 400 threads, to try to flush out whatever's going on. And finally, you find it. And you're like, oh, obviously, it's not random at all. We've got a 15-minute cache expiration, and there's a garbage collector sweep happening at the exact moment that the cache gets invalidated. And because it's a 15-minute window, if one of our customers is in Nepal, which is 5 hours and 45 minutes offset from UTC, of course that person's going to get a 410 gone every time. It's not random. It's deterministic. Now, when I talk about things being deterministic, I'm not just talking about the inputs to the function as arguments. I'm talking about all of the other things that affect the way that code operates. So you want to build the best calculator in the world. You can't just say, assert 1 + 1 = 2. You need to account for the environment you're running in, and the system clock, and the network information, and what kind of host you're running on, and the configuration, and all the things that we eventually figure out how to isolate those in our tests so that we can control the randomness. But once we've done all that, we get to a point where we can deploy software and we'd be like, well, it worked yesterday, it worked this morning, and we can be relatively confident that that is just going to keep on working. So we have this idea of digital determinism. The stuff in the computer is always going to do the same thing once we've worked how to compensate for the intrinsic variables there. Problem is, as we've already said, most people don't care about what's in the computer. They care about what happens when it produces outputs in the real world. You want to sit and watch a movie and eat popcorn with your family? Yeah, Netflix is great for that because you don't have to go to Blockbuster and rent a movie. You know, you want to order supplies for your new craft project. You want the real thing. You want the package. You want the pizza because you had a long day and you're too tired to cook and you want the food to turn up. And this is where we have the challenge, because reality is not deterministic. Reality is mostly what we call probabilistic, which means we can predict some bits of it, but not others. We cannot predict waves. We can predict the tides. We can tell you when the high tide and the low tide are going to be tomorrow. But if you're into big wave surfing, we cannot tell you the exact hour and minute and second when you should be out there to catch a really, really good break. We can predict how many people are going to be in hospital on Friday night. Can't tell you who they're going to be. We have these probabilistic models which are based on sampling large numbers of statistics. And some things, we can't predict those at all. We get, there's a Nicholas Nassim Taleb, the economist, calls these black swan events. We have a crash in the stock market. Well, now we don't know what's going to happen. We had a model, doesn't work anymore. Taylor Swift does an international concert tour. Nobody has ever seen anything like this. We have no idea how that's going to do. It's off the scale. It breaks the parameters to all of our forecasting models. Now, one of the perennial challenges of building software and developing digital products is trying to deliver this abstraction, this idea of pretending we can cause deterministic outputs when reality is still chaotic and random underneath it. Maybe the best example of this is the internet itself. The internet delivers packets around the planet with astonishing reliability. You know, you can do video calls with my mum in the Luangwa Valley. You can watch Netflix. You can send email and WhatsApp and Minecraft. All these things, they work because we can send a packet of data from here to anywhere else on the planet, and it's probably going to get there. It gets there often enough that we just assume it works. The internet runs on something called TCP, the Transmission Control Protocol. TCP is built on top of something called the Internet Protocol, IP. IP is not reliable at all. IP says, put a packet on the network and forget about it. We don't care. We're not going to keep track. We don't know where it went. We don't know if it arrived. And so the people who created TCP, their challenge was, how do we build a reliable layer on top of an unreliable one? And they did, and they succeeded. They have this elaborate dance of synchronization and acknowledgement and handshakes and packet numbers and all these amazing solutions to create the illusion that the whole thing is deterministic. Now, if any of you folks studied databases in college, there's another thing that we often forget about the relationship between technology and reality. Reality is a lot more resilient than I think most software engineers give it credit for. Studying databases in college, I remember the lecture about transactions. And the lecturer is saying, okay, now transactions are really important because let's imagine we're doing a bank transfer. So what we got to do is we are going to take money out of one bank account, and then we're going to put the money into another bank account, and then we're going to, and this has to happen as one operation, because if the computer crashes between those two statements, the money has disappeared. And if that happens to you, then you're going to go to programmer jail, because that's the worst thing you can do, and we don't do that, we're engineers. And then, you know, you get a little older, and you leave university, and you talk to people who work in banks, and they're like, oh yeah, money goes missing all the time. We've got an entire team whose job is to look for the places where this happened and try to figure out where the money went. And so reality is not deterministic, but it's also a lot better at recovering from its own idiosyncrasies than we give it credit for. But despite that, a lot of the work that we do is about trying to create this deterministic abstraction over a probabilistic reality. Now, within the last couple of years, we have seen a completely new approach, a new way of thinking and reasoning about digital software and product development, something which is going to fundamentally alter humankind's relationship with the way that we build information systems. That's right, folks. I'm talking about Java 25. I'm not. I'm talking about AI. I am talking about Copilot and Gemini and Grok and Claude and Sonnet and Cursor and whatever else it is that is happening this week and what. Now, The phrase artificial intelligence, we've been bouncing that around for 50 years now without anyone really being entirely sure what it means. For the purpose of this talk, I am using the current mainstream accepted definition of AI. AI is what happens when you click on this. That's it. If your product or your app has got this button in it and you click that, that's AI. That's AI happening. I'm also only talking about using AI to create software and write code. If you want to talk about using AI to make movies and write books and write songs, then you're going to have to come and find me in the bar where the code of conduct does not apply, because I have opinions about those things. But we have got to this scenario now where I've been writing code since I was 8 years old. You know, I have written code in Logo, and I've written code in BASIC and Scheme and C and C++ and HTML and CSS and JavaScript and SQL and Ruby and more JavaScript. I have been writing HTML since 1992. I learned Java in the 1990s because the future was going to be Java applets running on set-top boxes on top of your TV set, because that was how the internet was going to work. I fought in the browser wars. I fought for Netscape, so I guess we lost on that one. Point is, folks, I have been around, and I have spent my entire life immersed in the craft of developing software, and I have never seen so much of a gap between the hype and the reality as I'm seeing with the state of what is going on with AI right now. Now, let's imagine you invent a new kind of snack. Like somebody out there, some food scientists are like, oh, we got this amazing thing. It's a cheeseburger, but it's a kombucha cheeseburger, and it's blueberry flavored, and we're going to call it the boochburger. And you're like, oh, and you try one. And the boochburger it's amazing. Like, oh, wow, you got to try this. This is the most delicious thing you have ever tried in your life. It is just amazing. And, you know, it's a pretty miraculous product as well. It tastes great, but low fat, low salt, high protein. You could eat one of those. It keeps you going for the rest of the day. It is a miracle of culinary engineering. And then, you know, a couple of weeks later, you're in the grocery store, and suddenly it's like, oh, look at that. We got boochburger oatmeal and boochburger milk and boochburger cheese, and boochburger is now in absolutely everything. And there's some guy on CNN saying, well, you know, in a year, we won't need oatmeal and tomato sauce and cheese anymore, because we'll just be eating boochburgers for everything. And your friends out there who have jobs in, you know, restaurants and bars and stuff, they're all getting fired because their boss saw someone on CNN say, oh, we won't need restaurants anymore. We're just going to do everything with boochburger in a couple of years. And then there's a news story. McDonald's, a hamburger restaurant, they have invested $1 billion in boochburgers. And the CEO is like, I've tasted the future, and it is delicious. And you dig a little deeper. This isn't $1 billion in real money. What's happened is they've given them $1 billion in discounted franchising. So they can go and sell boochburgers through all these restaurants. The actual money, the real money here, is going to the people who manufacture the griddles that they used to cook them, because that's where the actual product in this that is changing hands is going. Now, there is a slight, just one tiny little problem with this. It turns out that boochburger has a little bit of a problem with quality control. Most of the time, the boochburger is delicious. Like, that is a tasty burger. Once in a while, like you heard, there's this friend of yours, they had a roommate, and the roommate's cousin had cancer, and they ate a boochburger one day, and the cancer went away. And they're like, it's amazing, it's a miracle superfood. But sometimes it comes out tasting kind of funky. Like, it tastes like cigarettes, or it tastes like peppermint, or it tastes like wet dog. Or sometimes it tastes very bad indeed, because there was a couple of boochburgers came out, they had depleted uranium in them. And we don't know why this is happening. Some kind of interaction between the natural fermentation and the Maillard reaction. And one time, there was a boochburger, and it was sat on the shelf and a thing, and it just exploded, and it took out half of a city block. Now, folks, it would be disingenuous to say that they're not solving this problem, because what they've done is they put a warning on the wrapper. Boochburger may contain surprises. Please enjoy with care. Now, the most astonishing thing about the boochburger, they're giving them away for free. You can walk into McDonald's anytime and be like, hey, give me a boochburger. And anybody with even the most rudimentary understanding of free market economics is looking at this and they're going, how does any of this add up? How are you going to get your $1 billion back that you invested in a product which is being given away for free most of the time, and they're putting it in absolutely everything, whether the consumers of those products have asked for it or not, and mostly it's delicious, and sometimes it cures cancer, and sometimes it tastes like wet dog cigarettes, and sometimes it blows up. How is anybody going to recover their investment? What's the future of all this? Now, of course, you look at the breakdown, you look at the way that the whole thing is actually happening. The real question is you're following the money. You're looking at where the investments are going. You're looking at the actual infrastructure that is happening. McDonald's has consolidated its position because it owes $1 billion worth of griddles now. That's going to be useful. They're a fast food business. You know, it doesn't matter if it's boochburgers or not. The people making the griddles, oh, they're laughing all the way to the bank. The CEO of Griddle Corps, he did an interview with Wired magazine. In 2 years, boochburgers will be more important than drinking water. And the rest of us, well, you know, what are we going to do with all of this? We should probably just be like, you know what? Let's eat the free burgers while they're free. Let's maybe try to figure out how to spot the ones which taste like exploding dog cigarettes and make sure that we don't accidentally sell those to our customers or feed those ones to our kids. And let's think about what we are going to do. Like, when those things stop being free, how much are we prepared to actually pay for them? And what are we going to do if that is more than we are prepared to fork over for it? Now, we could stretch this metaphor all kinds of ways. I could talk about, oh, yeah, do you hear the army? Yeah, the army aren't provisioning troops anymore. They're just going to feed them boochburgers when they get there. I could talk about the fact that McDonald's says it's going to open 50,000 new franchises next year. And the global construction industry is looking at them going, where are you going to get material and labor for 50,000 restaurants in 6 months? But, you know, let's bring this thing back to reality. AI is here. It's not going away. And anybody working in technology at the moment, I think you have to figure out the answers to 2 questions. What am I going to do about it? And what happens if I get it wrong? Now, to me, the biggest challenge facing us as engineers about incorporating AI and machine learning and language models into the sort of workflows that we do is that they are fundamentally non-deterministic. Underneath a language model, there is a massive vector database of tokens. Tokens are the building blocks of natural language, like little molecules of meaning, and the relationships between these tokens, which it can use to predict which token is the most likely one to happen next in the sequence. So if we give it a prompt like Dylan won the, we're going to get something like Dylan won the lottery, or Dylan won the game, or Dylan won the quiz, or Dylan won the contest. Because these are statistically probable tokens to appear next in that sequence. Now, the thing that makes these devices so powerful, these things so powerful, is something called context. Because you can give it context which will influence the likelihood of certain tokens coming up next. If we prompt a language model, Bob Dylan is one of the foremost songwriters of his generation, Dylan won the, what happens is that certain relationships in that massive database now become far more likely. Probably the one that pops up is Nobel Prize for Literature in 2016, which he did. Despite, you know, being a singer and a songwriter, Bob Dylan won the Nobel Prize for Literature in 2016. This is true. If we prompt it with Dylan Beattie took part in his primary school sports day, now the logical continuation is, well, Dylan probably won the egg and spoon race or something else that happened there. But what if we give it, Bob Dylan is one of the foremost songwriters of his generation. Now, there is a parameter in most language models called temperature. And temperature is just like, hey, how wacky are we going to be today? If temperature was 0, they would just be completely deterministic and you'd get the same thing every time. And that wouldn't be terribly useful because we already have machines that can do that. If you crank temperature up quite a lot, you get nonsense out. But what happens sometimes is you just get one token, the temperature on that one just kind of rolls the dice, and it gets something a little bit unexpected, like gold. And Dylan won the gold, and when you win the gold, the next word is probably medal, and then gold medal in, and then it's probably a sport. So now Bob Dylan won the gold medal in judo at the 1984 Olympic Games in Los Angeles. Now, there is nothing wrong with this sentence, other than the fact that it isn't true. It is grammatically correct, the spelling is accurate, it looks authoritative. You read that, you're like, oh yeah, I didn't know that, that's interesting, a man of many talents. Now, folks who work with language models, they refer to this particular phenomenon as hallucination. I really do not like the word hallucination, because hallucination is what happens when sentient conscious beings like us, when we see and hear things that aren't there. And so we are exposed to stimuli which are not real. Everything else we see is real. That's the fundamental distinction. Now, for something like a language model, nothing is real. Every single piece of output is fabrication. The problem is, a lot of the time, that fabrication aligns with our own understanding of reality, and so we treat it as fact. We think that it's accurate. And the bits that don't line up, we come up with, oh, well, it's obviously hallucinating. Poor little thing. Now, this gives us a whole new challenge because we have been talking for years. How many of you have ever had a conversation at work where you're like, oh, yeah, I see the problem. You are logged in, but the server can't decrypt your cookie, so it thinks you're logged out. And we know the server doesn't think because it's a server, and servers don't think. That's not. So we have this language, laptop is struggling because it's tired, it's overworked. We anthropomorphize. We project human experience onto the machines that we work with every day. But now we have machines that can give a pretty reasonable simulation of consciousness. We don't have the right words to talk about it. We say the computer thinks something, and there's people out there who believe that the computer is actually thinking. It's not. It's predicting tokens in a stream. Now, the question that this kind of always swings back around to is, will the future of software development, what does the future look like? And we had this phrase pop up out of nowhere in May this year. People started talking about vibe coding. And everyone's like, oh, vibe code, I don't know what that is, but it sounds important, so I'm going to start using it when I talk to people and in my social media posts, and I'm going to post about it on LinkedIn. And, like a lot of buzzwords, lots of different people go, oh, I'm doing this thing, that must be vibe coding that everyone's talking about. The definition that I find most useful for this is you give a language model a prompt and it writes you some code. You don't review the code, you just run the code. And if the code fails, you give the error message back to the prompt and say, fix this, and there's no kind of human involvement other than just giving it back its own error messages. Now, have you folks tried this? Have you opened up like Copilot or Gemini or Cursor, any of these tools, and you've just gone, hey, what I want, you build me a login system with PostgreSQL and put a backend on it, make it purple, use this font. Now, this video has been accelerated 50 times because it took about 20 minutes to actually do it. But I gave Copilot this prompt, build me a .NET login system. I told it what font I wanted. I gave it a color to work with, and it did it. And it's like, there you go, and I could go on, I could register, I could set up an account. And on the one level, this is pretty amazing. Look, it even, copyright, 2025 public, it's invented a fictional company that owns the code that it just generated from one prompt in 20 minutes. Now, looking through this code, there's some stuff that you're like, yeah, that's pretty good. Oh, look at that. It's validating the parameters to the database commands. And you're like, would I have thought to do that? Yeah, I think I probably would, but I'm not sure. But then, on the other hand, it's built a login system. Like, this is not going to set the world on fire. We know how to build login systems. It's very, very good at solving problems that we kind of already figured out how to solve, and sometimes synthesizing bits of solutions into something that solves a particular combination of problems. Now, I spend a lot of my time running workshops. I teach people how to code. Some of you folks will be joining on Friday. I'm doing a session here in Porto about how to build a ray tracer in JavaScript. And when I write the handbooks for some of these things, I always have the same challenge you have with any kind of technical writing, is I want to include code in the documentation. And when the code is code, we have tools that help us get it right. We have linters and formatters and unit tests. But when you copy and paste and put it in something like a Markdown file or a Word document, you can't use the tools anymore, so the code might have bugs. And so I have a set of, like a workflow I use with Jekyll and Markdown and using relative include, so I can pull little snippets of code files into my documentation and publish those as part of the handbooks for these courses. And it's a workflow I've been tweaking for a couple of years. And then a few weeks ago, I'm building a new course about CSS. And I'm like, I don't really want the whole thing. I want to be able to highlight the lines that are important. And I think, I know I can build a custom plugin to do that. But I'm using Jekyll. Jekyll is built on Ruby. It means the plugin needs to be built in Ruby. Ruby's not really my happy place. It's a perfectly good language, but it doesn't have enough curly brackets for me to feel at home. So I go into Copilot, and I say, hey, create a custom Jekyll plugin that'll let me specify the line numbers I want to highlight when including a code file using this syntax, and then this is what I want to put in my file. And I pushed go, and I went and I got a cup of coffee, and when I came back, I had included snippets with lines, and I was like, this is amazing. And of course, what happens then is I'm like, hey, this is awesome. I wonder what else this thing can do. Now, let me draw a deeply scientific graph here. This is time and features. So across the bottom, this is how many days I've spent working on this piece of code, and features, how good is it? How capable is it? What can it do? And in a parallel timeline where I am writing the code by hand, like an animal, like we used to in the Stone Age, what happens is the first couple of days, I'm just kind of reading the docs and figuring it out. And then I start implementing things. And there's the odd thing where I make a mistake or have a regression. But both the level of capability... Okay. Can you hear the interesting noise? Like someone's, yeah, cool. All right, good. It's not just, I'm not hallucinating. That's fine. So both the capability, the maturity of the software, but also my understanding of it is kind of climbing day to day until eventually I get to a point where it works pretty well and I'm confident in it. Now, what I started doing is I started asking Copilot to add different features to my plugin. Hey, can I give it an XPath or like a CSS selector and have it pull that piece out of the file and include that? Can I change the indentation? Can I combine different syntax highlighting? And what I discovered is it did this. That first one was like, woohoo, 20 minutes and you're up and running with it. And then I would prompt it, and it would be, oh, no, sorry, nothing works. Everything works. Everything works. At some points, now you see there where the graph dips below the axis? At one point, it managed to vibe code something which would delete files and then push them to GitHub. So it was actually worse than nothing because the plugin was destroying stuff that had already worked. And I'm going in and I'm reading through this code. I'm trying to figure out, okay, what? And what I sort of eventually realized with this thing is that the time spent, there is this illusion that every time you're iterating on the right answer, you're getting closer and closer to the magical prompt which will do exactly the right thing. But that's not really what you're doing, because the engine is non-deterministic, and that context window is sliding. So the thing you told it yesterday, it's probably gone now, unless you know how to bake that into the architecture of your project. And while I was sitting there one afternoon, kind of trying the prompt again and reverting and trying again and reverting, it made me think of a guy called B.F. Skinner. B.F. Skinner was a psychologist at Harvard University from 1948 to 1974, and one of his most famous experiments was about something called operant conditioning. He's one of the first people to research how can you influence animals' behavior. He used pigeons and he used rats in most of his experiments. How can you influence their behavior using punishment and using reward? Like you put a rat in a cage and there's like a mild electric current in the floor and there's a lever. How long does it take the rats to figure out that if they push the lever, the electricity goes off and this kind of thing? Now, he did a very, very famous experiment where he took a rat and he put it in a cage, and there was a lever in the cage, and in the first group, what happened is the lever did nothing. Rat pushed the lever, nothing happened. Push it again, nothing happened. The rat's like, all right, I guess I'm just a rat. It's fine, I'll get on with it. In the second group, every time you push the lever, it would dispense a food pellet. And those rats are like, this is pretty cool. I got a buffet. And they push the lever, get a food pellet. And when they were hungry, they would go and they would eat, and probably eat more than a wild rat would, but most of the time they just were pretty chill, and they got on with being rats. In the third group, the lever dispensed a food pellet sometimes. Not every time, but maybe they'd have to push it 5 times or 10 times or 20 times, but eventually they'd get a food pellet. The rats in that group, they actually went crazy. They got completely addicted. They stopped grooming, they stopped socializing, they just spent the whole time mashing the lever again and again and again and again and again, because next time you might be the lucky winner. Next time might be the one that gives you the food pellet. Now, let me ask you folks a question. How many of you out there have checked your social media since I started talking? Just like, sleekly, do I have any notifications? Because it turns out this thing, variable ratio reinforcement, you might get a food pellet, is an incredibly powerful motivating mechanism for influencing the way people behave. That's why social media is so addictive, is because it's not guaranteed, but every time you check it, you might have a food pellet. You might have a like, you might have a comment, you might have a thumbs up. Somebody might have reacted to your post. This is how casinos and slot machines work. It's how people get addicted to gambling. And even when you know it's happening, it can be incredibly difficult to break out of the cycle of doing it. I had another instance of this happen to me a couple of days ago. I was in Lisbon last week, and I took a train from Lisbon down to Coimbra, and then from Coimbra to Porto on Sunday. And when I travel on an aeroplane, I put my phone in airplane mode, and I have no data, and it's fine. I don't bother. Why would I bother checking anything? I know there's no signal. I'm offline. I'm just a happy little rat without any food pellets. And when I'm at home, I have gigabit wired fiber optic Ethernet to my house. I have all the data I can possibly want. When I go and I check social media, I check email or anything, it's absolutely fine. But when I'm on a train Wi-Fi is brilliant, right? I'll get signal. I'll be like, oh, there's Wi-Fi on the train, so I'll connect. And then I'll get a notification on, hey, someone sent you a message on Slack. But the train is doing like 150 kilometers an hour. So by the time I open Slack, I've lost the network. So I can't see. I know I have a message. I don't know what it says. And I'm like, refresh. Maybe I can tell that. And it's this. And I know I don't have signal. And the stupid thing is, I know that train Wi-Fi sucks. And I know that train Wi-Fi fundamentally sucks, and today is not the day that they've magically fixed all the train Wi-Fi, but every time I get on a train and I see they have train Wi-Fi, I think, well, maybe, and I try it again, and after half an hour, I'm like, no, come on, stop it. You know better than this, but I still get sucked into the loop every time. And so when we start incorporating things like language models, which have this intrinsic non-determinism, into the way that we build software, we are basically, hey, vibe coding. Do you feel lucky? You crank the handle and it's going to spit out 10, 100,000 lines of code. And sometimes that code is exactly the right thing. Sometimes that code it's perfect. It's exactly what you would have done, except it would have taken you all morning and it took the machine 30 seconds, 2 minutes, 5 minutes, however long. And so now you have the problem of, well, it generated 1,000 lines of code. Yeah, I should probably review it before I deploy it, right? Who likes reviewing code? Whose favorite thing? How many of you got into software because you're like, you know what I want to do? I want to read code. I want to read other people's code. I want to read 1,000 lines of code spread across 50 files on a critical piece of infrastructure project that the person who wrote it got fired yesterday, so I can't even go and ask them what they were thinking. Because that's why, and the temptation, when you got your boss breathing down your neck and deadlines, and everyone's like, oh, you need to be 5 times as productive now because we've given you AI tools, is just YOLO. Looks good to me. Let's get out there. Let's just ship the thing and see what happens when we deploy it. Now, I talked a moment ago about how software engineering is about delivering deterministic abstractions over this probabilistic, uneven reality. And I think the most important word in that sentence in the age of AI tools is the word deliver. Now, until fairly recently, if you wanted to use a computer to solve a problem, you had a choice. You could find a program that already did it. You need to pad a string or encode a JPEG, and you're using, we got a module you can plug in to do that. What is it? Oh, I need to search all these text files for a regular expression. Yeah, cool, grep, check it out. We solved the problem for you. Oh, I need to write a report and do an invitation for my kid's birthday and write a novel, and Microsoft's like, hey, we have a solution. Look, you buy this product, you install that. If there is no product off the shelf or on the NPM or the package manager or the Unix distribution that solves your problem, you could write one. And I'm sure this experience will be familiar to many of you folks out there when you've been sat at your desk and you're doing some like moderately tedious piece of work, like you're going through parsing JSON, and you're like, I could write a program to do this, because that would be more fun than actually doing it. I have hundreds of what I call little programs. Little programs are programs that help me solve one problem one time. They suck. The code in them is terrible. Some of them work on my machine. Some of them don't even work on my machine because they're hard-coded for when I ran everything off drive E, and now I have a drive D, so I need to go and edit the path file names. They don't have authentication. They don't have security. They don't have monitoring. They don't have any of the things that we take for granted about production-grade software. But that doesn't matter because that works on my machine. It's just little programs. Now, probably the single most significant thing, the thing to me which is the difference between a junior and a senior engineer, it has nothing to do with how fast they can write code or the biggest project they've ever worked on or how many times they deleted production, is that it's about understanding what is involved in going from a program to a product. Because programs are small and they're scrappy, and yeah, they took maybe, look at that, it took an hour, and now I've got a web form where I put things in and it puts them into a spreadsheet, and you're like, hey, that's awesome. We just invented online surveys. The product is like, no, we need authentication, you need security, we want telemetry, we need insulation against DDoS attacks, we need to make sure, did you test it with Unicode? Did you test it with right to left, like does it work with Hebrew, does it work with Arabic? What about Chinese? Do these things work? Accessibility, have you tested it with screen readers? What about this device? All the stuff which is not part of the happy path for a programmer, because we like to sit down, write code, and hey, look, the program works. And this is how I think we end up doing things like building loyalty applications that don't work on my device, and so they don't work as well as cardboard, is because of this boundary between the act of writing the program and the act of creating the product. Now, sometimes the software is not the product. Sometimes the software is just part of the process. Liam Westley, a friend of mine from London, we used to run a .NET group together. Liam has a wonderful story because he was working at a big British TV company in 1997 covering the general election. And the way elections work in the UK, they're about every 5 years, but you don't know the exact date until 3 weeks in advance sometimes. So Parliament says there's an election 3 weeks. Suddenly Liam and his team are like, we need graphics software. When? 3 weeks from now, we're going to have millions of people watching TV all night, and we need a way of putting these cool interactive graphics on this big map showing you which constituency won. And what they did is they hacked together a program in Visual Basic 4 that would put graphics on. They sent it to a broadcast capture device, and they had developers sat in the room all night while the live TV feed is happening. And at one point, they were getting data in from a newswire service, and there was a bug in the newswire. So they literally had someone with the Visual Basic editor open with a breakpoint, and when the code hit that breakpoint, they had to go into this big array of data, and they had to edit one of these numbers and reduce it by 500, because that was the error. And then they push F5, and it runs, and that goes straight out live on national television to millions of people who are tuning in to find out who is going to be the next Prime Minister of the United Kingdom. Now, you see how a certain kind of entrepreneur would look at that system and be like, oh, we should sell this. We should get into doing broadcast graphics. That's a big... No. The software is not the product. The television is the product. The thing they are delivering is the software is never going to get used again. It's not going to be 5 years later. Someone is going to be, hey, can we get the VB4 thing with the breakpoint up? They'll have a different system for it. It needs to work one time, once, for one night. And the thing about live TV is the people who produce it, they are used to stuff going wrong. If your VB app crashes, they'll just cut to the studio or cut to camera or go to a commercial break or something while you fix the bug. It was the perfect solution to that problem, even though the code was objectively not something you would ever ship as a product. Star Wars, 1977, the visual effects in that movie have stood the test of time. It is an astonishing testament to the innovation that they had in Hollywood and the creativity at that time. The tools, the equipment, the motion capture rigs and the cameras that they used to make the movie, those broke down every single day. They were literally running equipment until it collapsed just to get the shot. The shot is the product. The process is not the product. When Queen recorded Bohemian Rhapsody at Abbey Road Studio, the magnetic tape that they recorded that song on did not survive the recording process because they overdubbed so many times. By the time they were done, there's no magnetic data left on the tape. The tape died as the process. That is still the most popular song in history. It's the most listened to song of the 21st century. We are surrounded by books and light bulbs and post-it notes and batteries and all of these, everyday products that make our lives a more interesting and a better place to be, which were the outcome of a chaotic creative process of human engineers and authors and writers just trying out a whole bunch of different things. Maybe it'll work, maybe it won't. That's the non-deterministic part. And eventually they're like, right, I think we've got an approach for this. I think we have something that's reliable. Let's turn this into a production line, and then we can mass produce this thing. Now, as far as it comes to, shipping vibe-coded software and that kind of thing, my little Jekyll plugin that I vibe-coded, I'm not shipping that. I would never send that code to a customer. It's on GitHub if you want to go and look at it. I don't know if it's any good, but that's not the product. The product is the handbook. The product is the HTML, and I have reviewed that, and I know it does the right thing, and so I am happy putting a stamp on it and going, the thing I'm actually delivering to you, that's mine. I've tested it. My name is on the commit. If it doesn't work, that is on me. Now, this is why, the current generation of AI tools, they are very, very good at writing little programs. And they're very good at finding solutions to problems we already solved and adapting them to work in the context of your own project, those kinds of things. But turning those little programs into digital products and software, that, I think, is always going to require the human in the loop. To certain kinds of engineers, AI, it's a useful tool. It's something we can reach for that the thing you have to do today, hey, maybe it'll speed that up. Maybe it'll point you in a direction you wouldn't have thought about otherwise. Maybe it'll vibe code the whole thing and it'll get it absolutely right. But if I'm putting my name on that commit, I'm not doing it until I've checked all the code. And at that point, it doesn't matter who wrote it. It matters that I've looked at it and I'm confident it's good and that I'm prepared to say, this was me. If this thing blows up, then you can shout at me about it. And I'm not going to say, oh, it was AI. I'm going to say, I'm really sorry, I screwed up. I will fix that. Now, there is another angle to all of this, which I think is pretty exciting. The way that I learned to build web applications, Microsoft Access 97 had a thing called the Publish to the Web wizard. And you could build an Access database, and then you could go in, and it said, what do you want to create? And it could turn your database into a website. And it had a thing called Microsoft Active Server Pages. Now, I did not really know what Active Server Pages were. I didn't really understand the tech. I hadn't worked with it, but I didn't care. I could click the buttons and make a thing happen, and then I would get a website, and when I edited the database, the website would update. And this is magic. This is like, 1997, 1998. This is cutting-edge stuff. And then one day I was like, well, what is this ASP file I got here? And I opened that up in Notepad, and I'm like, oh, this looks like HTML with special source. I wonder what happens if I change the HTML, and it worked. And I wonder, oh, can I copy and paste these little chunks of weird with the angle brackets and the percents? And I did. And I had no idea I was working offline. I didn't not have an internet connection. I was doing this on a laptop with no modem, but I was figuring out how to build data-driven applications because I had a machine that would create ones that already worked, and then I could dismantle them and pull them apart and see how they behaved. And now, for some kinds of people, they learn well from watching videos, reading books. Some people learn well from structured classroom exercises. I learn by taking things apart and seeing if I can put them back together. That's my best way of really grokking how something fits together. And so to me, the idea that an aspiring developer could sit down and go, hey, build me Tetris in Python. And it'll build them Tetris in Python. And then they can take it apart, and they can see, how do we do graphics in Python? How do we do keyboard input in Python and try and put it back together? That, to me, is quite an exciting prospect because it opens up another career pathway. It's another way that people out there who want to understand the craft of programming can get examples to work from. And sooner or later, they're going to start finding the bugs. And they're going, that's weird. And at that point, they're going to have that moment of realization. The LLM will mostly get it mostly right, but it's not bulletproof. Is it going to replace us? Is AI going to replace software engineers? Now, at this point, we got to do a bias check on the room because I have talked to a lot of people about this. The correlation that I have observed, anecdotally, this is not a rigorous study, the people who know a lot about programming say no. The people who don't know anything about programming say yes, and most journalists do not know anything about programming. Now, I'm biased. I like writing code. I quite enjoy the fact that I can get paid to do it because it's nice having a job that's also fun. I also do not want to live in a future where the banks and the airlines and the hospitals are running software that got vibe coded by the boss, and when it breaks, they're like, well, you have to ask the chatbot for support, and the chatbot says, oh no, your flight is on time. Yes, Uncle Frank is fine. The money's in your bank account. Hey, you hear about the time Bob Dylan won the judo at the Los Angeles Olympics? It's not a future I want. But, accounting for bias, no. AI is not going to replace human developers. Not anytime soon. Not the current generation of AI tools. It's very, very good at synthesis. It's very good at recycling components of things we've already got, putting them together in a new way. It is fantastic at doing, hey, I have the answer to my problem, but the solution I found is in Java, and my program needs to be in Erlang. Can you kind of get me started on translating between those two things? It is a whole new set of tools that we can use to solve problems. But I think actually creating good quality, usable digital products, things people want to use and are prepared to pay for, that is still going to require humans for a long while left to come. Maybe another way of looking at it, we got all these companies out there now who say that they have tools that can replace human developers. Let's imagine that you had a tool that could replace human builders. You had a thing that you could give it a prompt and it build you a house, and it can do it in like 3 days. So you get a plot of land, you put your thing in, boom. 3 days later, there it is. It's got electricity, the water's in, the roof, windows, everything. It's ready to move into. If that was you, would you be out there going, hey, who wants to invest in my house building machine? Or would you be building houses as fast as you can and selling them on the open market and making an absolute fortune doing it and trying to make sure that nobody found out about your house building machine? Because if I had a machine that could do that, the last thing I would be doing is trying to get my competitors to invest in it. I would be making bank. If AI could replace human developers, we'd have fixed all the bugs, and there would be a dozen new competitors to entrenched products. We'd have alternatives to Adobe and Microsoft popping up out of the woodwork that we're undercutting. I don't see any of that stuff happening. I see a lot of conversation about it, but when it comes to actually creating the products for which there is a market, I do not see that stuff happening yet, and I don't see it happening with the current generation of tools. Now, I'll just take a second to talk to any of you folks out there, and any of you folks out there watching on YouTube weeks or months after we did this thing for real, you're at a point in your career where maybe it's early, maybe you're about to choose what you're going to study in school, or you just graduated, or you're thinking about a career change. What should you learn? What does it make sense to sit down and learn in the age of AI? And my advice to those folks, and this is opinionated advice from a middle-aged white guy, is first of all, take the code that AI is going to write for you and read it and figure out how to find the bugs in it, because that is going to be a reality of our industry. It may end up becoming an entire chunk of our industry, is fixing vibe-coded software that's almost right, but we can't find the bugs in it. Now, invest in learning things that aren't going to change. In August this year, OpenAI, they upgraded ChatGPT 4 to ChatGPT 5. They just said to everyone, yep, it's gone. 4 is gone. 5 is the new hotness. That's the one you're using now. And people got really, really upset because they had spent thousands of hours interacting with ChatGPT version 4 to the point where they felt like it had a personality. They felt like they were investing in a collaborative relationship. They felt like it knew them. When they upgrade to GPT 5, it's different. The tone is different. The language is different. The little jokes and references and things are different. There's this massive backlash. OpenAI eventually say, well, you know what? We'll reinstate 4.0, but only for paying customers and only for a limited time on there. If you really want to go all in on working with AI and language models and maybe figuring out how to build and train these things yourself, you've got to figure out how to do it locally. So there's a tool out there called LM Studio. It's a good place to get started. There are others. LM Studio just lets you download all these models, run them on your own machine, figure out how they work. Now, you need a powerful machine. You don't need a data center, but you probably want 128 gigs of RAM. You're going to need a couple of terabytes of disk space for all this. You're going to need like an M3 or an M4 Mac or one of the new NVIDIA GPUs. But that's fine, because you can buy that, and you can tell your accountant that it's an investment in your profession, and those are really, really good at running computer games. They are fantastic gaming rigs as a neat little side effect of all this, and just don't tell your accountant what you're doing with it over the Christmas holidays. Learn stuff that isn't going to change. HTML isn't going away soon. CSS isn't going away soon. JavaScript isn't going away soon. This is baked into browsers. Browsers are how normal humans interact with the web and the rest of the world. There are really smart people working on getting new standards, new AI techniques, new APIs into the way the web works. This stuff is also fun. It's bright, and it's got things you can click on and pictures and pretty buttons, and it's really, really fun building stuff with it. And the stuff that gets baked into browsers, they're not going to switch that off one day in August because they felt like it. That's going to be there 5, 10, 20 years. Learn a back-end language. Learn C# or Java first, because they use those in banks, and banks have money, and money is nice. Then when you've done that, learn Python or learn Ruby. Learn something which has a different way of looking at it. And then learn Scheme, because if you know Scheme, JavaScript makes a lot more sense. Do the stuff which is going to keep you relevant. And probably the single most important piece of career advice, you got to learn to spot bullshit. Now, we have machines now that can do bullshit, but if you've ever worked with a particular kind of sales executive or certain kinds of recruiters, you'll have had the phenomenon where you're having a conversation and your conversational partner is just regurgitating words that they read in a magazine last week. They don't know what the words mean, but they're trying to sound intelligent. It's basically what LLMs do. They just happen to get it right a lot of the time. At least when you're working with a language model, if it gives you a piece of code, you can run the code and see what happens. You don't have to take it at face value. If it tells you a piece of information, go and verify it. Look it up somewhere. Because the faster you can take the thing you've got in front of you and determine, is this correct or not, the faster you can either fix it or you can ship it and get on with whatever the next thing on the backlog is. Now, it's kind of a scary time. Jeff Bezos said last week that the AI bubble is good because it will eliminate the weak. That doesn't sound like a good thing for anybody to say ever. We are in a bubble, you know, the amount of money and investment and excitement that's been poured into AI, at some point, some of that has to come crashing down somewhere. Now, there is one side effect of all of this which I think is going to be positive. The folks on LinkedIn who are going in hard on the whole, hey, let's vibe code all the things, and I saw this post, you know, our design partner meeting in 48 hours, the platform wasn't ready, so I decided to put my Claude code swarm to work at 34 filthy React components. Now, if you watch people who don't understand programming doing vibe coding, what they'll do is they'll be like, build me a login system, and it'll do something. And they'll be like, yeah, build me a login system, but make the background blue. And like, no, they should be able to log in with an email address. And they go around, and by the time they get to the end of it, what's happened is that the AI has taught the product owner how to write a good spec. And that's nice. Because a couple of years from now, the people who realize that vibe coding is in the future, they'll have spent 2 years having to ask for the thing they actually want, and having to explain why it's important, and what color it should be, and what devices it supports, and all that kind of stuff. And I cannot wait to work in a future where the product owners have had 2 years of having to teach machines to get it right. Of course, it's not just the product owners. I saw Scott Hanselman do a demo in Lisbon last week where he was talking about this thing where you get one AI to write a spec and then you feed that spec to another AI. And this, to me, was really quite an sort of engaging proposition because, you know, you want to write a spec for it, and there are tools now that will say, well, you know, what does this thing want to do? And they will generate something like this. This is the one Scott showed in the demo last week. And I'm looking through this, and I'm like, this is really good. That's the data sources. This is the framework spec. We got a back-end data layer there, the performance. It's got performance targets. How many of you ever had a client go, the website's too slow? And you're like, you didn't give us a speed. You just told us make it fast. We made it fast. If you'd given us a performance metric, we'd have hit it. Layout principles. You know, this is the kind of spec that I would love to be able to work from as a developer. And to me, it doesn't matter whether the spec was written by a human or a machine. And it doesn't matter whether the spec is then given to a human or a machine to implement it. The fact that it exists as this kind of inflection point in the process, something that human beings can look at and be like, yep, that's not right, fix that one. But also then, if you do end up in the position of having to review that code base afterwards, you can refer back to that spec, and it'll tell you what it was supposed to do. And you can compare that to what it does do, and if there's a bug, you're like, yeah, okay, I see the problem. It's, they said 12 to 16 pixels, we've used 24 pixels, no problem. That's easy to fix. Now, we've been here before. This is another deeply scientific graph. This is time, and this is intelligence. And to calibrate our axes on this graph, this one here, that is average human being, and this one here is a ginger cat who's got his head stuck in a paper bag. Now, I'm going to subtly recalibrate that, because I think human intelligence is starting to decline ever so slightly, but maybe that's just I spend too much time on social media. Now, what we have had over the last couple of decades, 1960s, there was the Dartmouth Convention on Artificial Intelligence. 1964, a lot of people get very excited, and they go on and they invent Lisp, and they invent symbolic algebra, and they invent functional programming. And in 1970, Marvin Minsky, one of the leading lights of that generation of AI, does an interview with Life magazine where he says to the entire world, oh yeah, by 1973 to 1978, we are going to have a machine that is smarter than a human being. I think he probably believed that at the time, because if you look at the rate of improvement in the decade leading up to that point, that is just, you know, unbelievable. And of course, he's broken the cardinal rule of software development. You never, ever, ever tell the customer a date when the product is going to be ready, because they're going to hold you to it. And of course, everyone forgets about 1973 to 1978. Now, well, that's 1973. Minsky says 1973, a machine smarter than a human. And of course, it doesn't happen, because they hit the limits of what you can do writing Lisp on a PDP-10. Then 1980s comes around, and suddenly we've got this new thing. It's called expert systems. You can program a computer with all the information about all of the cars in your catalog, and then the computer can help you choose the right car. And this was artificial intelligence. Well, they didn't call it that because a lot of people lost their pension on the first crash. And so they're calling it expert systems. And this is, you know, the future of machine intelligence. And of course, it's not. It's just it's an expert system. We build those now, but we don't call them AI. And yeah, by 1990, well, no, we just need to build a big enough database. And it'll, no, that's not how it worked. And then the 90s comes around. We have neural networks. We got a machine that can beat Garry Kasparov at chess. We've got machines that can play Go. We've got machines that look like they might be able to drive cars. And of course, woohoo, yeah, 5 years. And no, didn't happen. And then the web comes along. And then neural networks turn into vector databases, and vector databases evolve into language models. And now we have this massive data set of all the pages on the World Wide Web, which are machine readable, and they're indexed, and we've got tagged images. We've got this massive corpus of training data. And of course, we get very excited, and we build a new generation. And of course, people are saying within 5 years, we're going to have a machine which has the intelligence of a human. And I don't see it happening, you know? There are two things that I think are wrong with this graph. One is I actually think the gap, language models are pretty amazing, but I think the gap between that and general actual intelligence is a lot bigger than anyone gives it credit for. And also, I know a ginger cat who sometimes gets his head stuck in a paper bag, and the other week I said to him, hey, could you vibe code me a login system using .NET and PostgreSQL? And he didn't. What he did is he snorted at me, and then he ate a snack and had a little sleep. And I was like, you're one smart cat, you know that? So I think that's the kind of level that we're batting at. The bubble that we are in, it's going to burst. A couple of companies are going to go bankrupt. Some people will lose money. Some people will make money. The whole global economy is going to rattle around for a little while. It will settle. We will reach a new kind of equilibrium, and then we will look around at what we've got. We probably won't call it AI. We'll call it assistive coding, we'll call it Copilot, we'll call it Grok. The phrase AI will pop up again in about another 10 years. And this time it might be quantum. And quantum AI might be really, really quite exciting. But the thing about the current generation, language models are trained on the past. All they can ever do is recycle stuff that already happened. They don't have the capacity to genuinely innovate. The first time I read The Hitchhiker's Guide to the Galaxy, it's about 10 years old. Now, Hitchhiker's Guide, people say it's a science fiction book, but it's not. It's social commentary. It's got aliens and androids and spaceships in it, but really it's about a guy from England who gets upset because they demolish his house and then they demolish his planet. And when the Vogon constructor fleet arrives to demolish the planet Earth to make way for a new hyperspace bypass, Douglas describes it with this wonderful sentence. He says, the ships hung in the sky in much the same way that bricks don't. Now, I laughed my ass off when I read this, and I still think it's I had never read a sentence like this before. Nobody wrote sentences like this before, because this is a completely new way of composing language. Now, The Hitchhiker's Guide to the Galaxy, it was a radio series that became a book, that became a TV show, that became a Hollywood movie, and along the way, it was a computer game. And that computer game, this is the early 1980s, what Douglas Adams dreamed of is an interactive fiction game where you could say something like, get out of bed, take some aspirin, drink a cup of tea, and get dressed, and the computer would understand what you told it, and it would tell you the consequence of that action. But in 1982, when this came out, all the computer could do was say, we use the word get in a way I don't understand. It could understand two-word code. It should just about do get up. Get up, go north, drink tea, those kinds of things. The game was fiendishly difficult, not because it was clever, but because the parser didn't understand what it was that you were trying to get it to do. Now, Douglas Adams came back to this idea of interactive fiction again and again. In the late 90s, he worked on a project called Starship Titanic, which was this wonderfully immersive visual computer game, great jokes, great graphics, fantastic soundtrack. It was still really, really difficult. It had a natural language parser with a vocabulary of 30,000 words. It had 16 hours of recorded dialogue, but it still was not quite up to the standard. You know, it was still a fiendishly difficult game for the very, very simple reason that it didn't always understand what it was that you were trying to get it to do. And so you couldn't solve the puzzles because it didn't know what you were asking it for. Starship Titanic was the last thing Douglas worked on. He died of a heart attack in 2001. Now, I think about Douglas a lot, partly because he was 49 years old when he died, and he liked guitars, and he liked computers, and he liked throwing parties and going on holiday. I'm 47. I like guitars, I like synthesizers, I like computers, I like going on holiday. But I took my blood pressure this morning, and I got a 22 out of 10, so I'm smashing it on the old health scale there. But I wonder what he would have made of the current generation of language models. You know, you imagine combining something like ChatGPT with something like a book, with something like, you know, it would be a completely new kind of entertainment. It's like a cross between improvising comedy and playing a computer game and reading a book. And you could say, get out of bed and take some aspirin and drink a cup of tea and get dressed. And the computer would be like, okay, yeah, you drag yourself out of bed, but you can't find the aspirin and the room is still spinning and occasionally swaying gently backwards and forwards. Now, I suspect that if Douglas was around today, he would have loved working with these. He'd have been training his own language models and getting frustrated by the fact that the machine got the idea, but it couldn't get the jokes quite right. And then somebody would have turned up and taken him away and locked him in a hotel room and turned off the Wi-Fi because he had a book to write because he signed a contract to do it. It is a scary time to be kind of staring down the barrel of history and wondering what is going to happen next. Lots of things are up in flux. The economy is looking a little bit precarious. But I want to give Douglas the last word on this talk because in The Hitchhiker's Guide to the Galaxy, that's a book about a book. It's a real book about a fictional book, a digital guidebook, a little device you can put in your pocket which basically has travel guides. It's basically a Kindle. Douglas wrote a book about the Kindle 30 years before Kindles actually got invented, and he knew that in fiction and in reality, people are often afraid of technology, even benevolent, useful, well-intentioned technology. And so on the cover of his fictional book, it says in large friendly letters what Arthur C. Clarke has called the best advice that you could possibly give to humankind. It just says, don't panic. Folks, thank you very much.